For more information, please visit SGMAK Associates website.
In this module, I'm going to explain two problems. Just converting cash flow into making decision. So the first one is a typical problem, how you build a portfolio. Or you can think about this is a plan maybe for your children education. So what you want to do is, with the problem is stated, you're making quarterly deposit 4 times a year, a uniform amount, to build a fund that will give you $5,000 each year, end of year, the last 5 years of the plan. So this is a 15-year plan. So in 15 years, you want to build a portfolio by depositing quarterly amount, and that will give you $5,000 end of each year over the last 5 years. So question is, how much money you should deposit every quarter? The fund is earning 6% APR, and that doesn't change over the planning period. 6% APR, 6% annual percentage rate, and it's being compounded quarterly. So next you can see the cash flow diagram. So since the planning period is 15 years, we have 60 quarters, 60. A shows the annuity payment, a known amount, and if you look at the cash flow diagram, our last 5 years in terms of number of quarters is end of 44th quarter, 48th quarter, 52nd quarter, 56th quarter, and 60th quarter. That's when you want to withdraw $5,000. So let us, so the parameters are in 60, plan period 60 quarters, interest rate per quarter is 1.5%. The problem we are solving in terms of future value. So you have moved the cash flow to time t equals 60. For convenience, it could have been solved in terms of present value also. So we're moving all the cash flow to time t equals 60. So we have set up this equivalence equation. A times f over a 1.5% 60. The factor on the left in the equation gives you the future value of all the money that you put into the fund at the end of time t equals 60. On the right hand side, that should equal to the amount you're withdrawing. You have $5,000 payment. So 5,000 times f over a converts the annuity to future value. Note that we got a new interest rate I prime and time period 5. I prime is the effective annual interest rate when you are compounding 4 times a year, 4 quarters, and each time period interest earned is 1.5%. So I prime is the effective rate and comes out to be 1.06 divided by 4 within the bracket raised to the power 4 minus 1. That's the effective annual interest with 4 compounding period and 1.5% per compounding period. And that comes out to be 6.13%. That's the effective annual percentage rate. With that number, your f over a factor comes out to be 5.64. So solving the equivalence equation, we get the annuity payment comes out to be $293.09. So what you're saying that based on your plan, if you deposit $293.09 every quarter for 15 years, that means for 60 quarters, that will allow you to withdraw $5,000 end of last 5 years of the plan, while the fund is earning 6% annual percentage rate. Let's move on to another example. You want to purchase a new car that costs $25,000. You got to pay 6% sales tax, and cost of title is $450. So $25,000 car, 6% sales tax, an additional cost of title $450. Dealer will finance 90% of the total amount. So you're making 10% down payment and borrowing money from dealer for the 90% of the total amount. And your repayment plan is over 4 years, 48 months, and you'll be paying at the rate of 6% APR, 6% annual percentage rate, compounded monthly. So making 48 monthly payments. So you want to find out how much cash you are paying, you have to pay right now, and what's your monthly payment. So the total loan amount is, you add 6% of the sales tax to $25,000, and we add separately $450. So that gives us $26,950. Total loan amount is $26,950. 10% cash payment gives us $2,695. So that's what you got to, that's what's your down payment, about close to $2,700. The loan amount, the remaining amount, is $24,255. So that's the money you're borrowing from the dealer. Repayment plan 48 months. Interest rate per month is 0.5%. So we use a simple, so dealer can use a simple capital recovery factor. The dealer is giving you $24,255 loan. So we use the capital recovery factor on the loan amount. So monthly payment comes out to be 24255 multiplied by the recovery factor A over P at 0.5% per month and 48 months. So A over P 0.5%, 48 is the capital recovery factor for this, and that comes out to be 0.0235 if you borrow $1. So your monthly payment comes out to be 24255 multiplied by the recovery factor, which is $570. So the way the problem is laid out, in order to buy the car at 6% sales tax and additional cost of title $450, your immediate down payment is $2,695, $2,695, and the remaining loan amount that's being financed by the dealer for a 4-year plan at 0.5% monthly rate comes out to be $570 per month. Okay, so this is simple. Just example one is building a portfolio, and the interesting thing about the first problem was different time bucket. You're depositing every quarter, but you're withdrawing end of each quarter. So you had two different interest rates. One was per quarter, and then equivalent, you're going to find out equivalent annual percentage rate. And the second problem was a simple cash flow. This is how typical loan is paid. You make some down payment, the remaining you borrow from bank, and then you have a repayment plan. So both are applied, and hopefully you find these two problems useful. Thank you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.